Well, hello everyone. Welcome to the lesson on factoring quadratics. We're going to start with this function x squared, or expression x squared plus 7x plus 6. You can see there are different methods that you can use here. Some people, they just factor it out right away using the theorem, Viete's theorem. Some people like the x method or a star or a snowflake, and some people like the box method. We're going to look at all three of them right away. We know that we have to put an x inside of parentheses. I'm going to start with this method, and then we have to think about the last number 6 and think about which two numbers multiplied give you 6. It can be 6 and 1, or perhaps it's 2 and 3. We're not talking about negatives just yet. And then you have to think about which two numbers, if you put a plus between them, which ones will give you this middle number. 6 plus 1 equals 7, 2 plus 3 does not equal 7. So we have to have 6 and 1, and voila, you have your answer. If you are using the x method, you will put 6 and 7 on the vertical one, so 6 on top, 7 on the bottom. Sometimes people put the other way around, 7 here and 6 over here. And then you have to think about, again, two numbers that multiplied give you 6 and added up give you 7. 2 and 3 doesn't work. So you think about something else and you will have 6 and 1. Same thing this way, depending on the school, depending on the teacher, you might use one way or another way. Finally, let's take a look at the box. The box gets a little bit trickier. You have to put the first term x squared in the upper left box. The last term 6, you put it in the lower right box. And then you think about, how do I get x squared? Using the area model, you think an x times x is going to give me x squared. How do I get 6? Probably I can multiply 2 and 3 to get 6. So then you're multiplying this 2 times this x, kind of like vertical and horizontal, right? Like this and like this. And then you get 2x over here. To get a number over here, you're multiplying this x times this 3, you get 3x. Now we check. 2x plus 3x, does it add up to 7? Oh, no, it does not. So that means that our 2 and 3 did not work. We have to think about something else. We already know that the answer has to be 6 and 1. They're both positive numbers. So you have 6x, you have 1x, which is x, and then both of those numbers together give you 7x. We check, we get the answer x plus 6 times x plus 1. What if I have, instead of a plus sign, I have a negative sign? That means that my first term has to be x in parentheses, and now I'm thinking about 6 times a negative 1, or maybe it's 2 times a negative 3, or maybe it's negative 6 times 1, or maybe it's negative 2 times 3. So I have more options here. Still, I have to think about, if I add those numbers, I have to get a 1 in here. There is invisible 1. We don't really write it, but it's there. 6 plus a negative 1 does not equal 1. 2 plus a negative 3, close, but not yet. Negative 6 plus 1 doesn't work. And finally, negative 2 plus 3, it will work. So we'll have to put negative 2 plus 3. Same way with the other two methods. We put negative 6 and we put 1, and then we end up with negative 2 plus 3. How does the box method work? Same thing. We have x squared and then we have negative 6. How do we get x squared? It's x times x. How do we get negative 6? Negative 2 times 3. If we make a mistake, same thing, we will check what we get here, negative 2x and then 3x. We will add up this diagonal and see if it adds up to just an x. In our case, 3x minus 2x does equal x. Now, let's change our negative from the last term. Let's say the negative is in the middle term, x squared minus 5x plus 6. Again, 6 is easy. We're back to our first case when it was easy to figure out 6. So it looks like maybe it's going to be 6 times 1 or 2 times 3. But 6 plus 1, 2 plus 3 is going to give us a positive number, which tells us that both of those numbers, they have to be negative. So now we have 6 minus 1, and then we have negative 6 minus 1 and negative 2 minus 3. Which one gives us negative 5? It's the second one. So we have to put x minus 2 times x minus 3. Same thing with the other methods. 6, negative 5. You have to think, you have to go through the same thinking process. And you will end up with negative 2 and negative 3 because other numbers, if you try them, they will either not add up to the right number or will not multiply to the right number. With the box, we start the same way. We have x squared. We have our positive 6. And we have to have x and x. And because we know that those numbers should add up to something negative, that tells us, that gives us a big hint that we have to have some negative numbers here. So negative 2 and negative 3. We already know we're going to get negative 3x, negative 2x. That will add up to negative 5x. But if we have now trinomial or quadratics with a coefficient in front, then it gets a little bit more complicated. We have to put 2x times x, because those two numbers multiplied will give us 2x squared. But then when we have our numbers multiplied to 6, we cannot simply add them add them to figure out which sum equals 1. We have to take these two into account. So I'm going to get to that a bit later. Let's take a look at some other methods first. So this x method now is being transformed into a star or a snowflake method, where your teachers probably told you to do this. You will put 2 and 2 over here, so that's the first coefficient. Then this coefficient, our invisible one, goes on the top, and then negative 6 does not go on the bottom. But what goes on the bottom is 2 times negative 6, negative 12. Why? Probably the teacher did not explain it to you. I'll get to that in a moment. Then you're thinking about numbers that will multiplied will give you negative 12, and then added up will give you 1. I think it's going to be 4 and negative 3. 4 times negative 3 is negative 12. If you add them up, you're going to get 1. Now, what do you do with all those amounts of numbers? You are going to take these two numbers and these two numbers. You're going to simplify this as if it was a fraction. For example, you can simplify this as 1/2. This one you cannot really simplify. This 1/2 is going to tell you that you will have 1x plus 2, and then this guy is going to give you 2x minus 3. So if I go back to my original method, Viete's theorem method, then I will have to have 2x minus 3 and then x plus 2. So in this case, again, I'm thinking about negative 3 times 2 is going to give me 6, but then I have to do a little bit more of mental math. I will have to think about negative 3x plus 4x. That will give me 1. Finally, the box method. You will have to put 2x squared in here and negative 6 in here. And that means that we have 2x and x. And then for negative 6, again, we will have to kind of play with the numbers and think about, okay, if I put negative 1 and 6, what do I get? I get negative x, I get 12x. Do they add up to 1x? No, they don't. So I have to erase and start all over again. You can write it, or you can draw many boxes, or you can kind of do a mental math. So then if you think about negative 3 and 2, finally you will arrive at that. You will have your negative 3x, you will have 4x, and then you can see that those two numbers add up to x. So that means that our answer is 2x minus 3 times x plus 2. So as you can see, there are different methods of solving those. Let's try to apply those to x squared plus 2x plus 2. Well, this 2 has only two multiples, well, 2 and 1 or negative 2 and negative 1, which we know are not going to work for us because we have a plus sign here. So if you add them up, you're going to get a negative number. So that obviously doesn't work. But 2 plus 1 equals 3. It does not equal 2. It doesn't work either. So what does that mean for us? That means that this guy is not factorable anymore. And how can we solve it? Not factorable. We can solve it by completing the square. A very simple method that I am not discussing right now. You can get this x plus 1 squared and then plus 1. And then we can solve it from there. We just saw that this expression is not factorable. And if you want to do something with it, we need to complete the square. Well, I know from experience that completing the square is one of the hardest topics in the whole unit of quadratic functions. And that is why I recorded a lesson on completing the square. And another secret method that makes completing the square a little bit easier. I'm not going to tell you about it. You would have to watch the next video. However, I know that if we get something for free, then usually we're not really invested in that. And that's why I'm asking you, no, not to pay me, but to invest in your education and to pay a little bit for the next lesson. The price is only $20. However, if you DM me this magical word square that you see on the screen right here, DM it to me on Instagram within next 30 minutes, you are going to get a 50% off. So for the price of just $10, it's what, like a cup of coffee and the bun or something, you are going to get a lesson on completing the square with details and a secret method that is going to make completing the square much, much easier for you. So do not delay, go to Instagram, DM me word square, and you're going to get instructions on how to get your next lesson on completing the square. I'll see you then.